All right, Advent of Code day 9. Here we go. So let's, where did we leave off? We left off at day 8. And now day 9 is available. Oh, that's weird. It looks like there's a space between 8 and 9. I don't know if that's intentional. It is. Interesting. All right, day 9, encoding error. With your neighbor happily enjoying their video game, you turn your attention to an open data port on the little screen in the seat in front of you. Oh, that would be tempting. Though the port is non-standard, you manage to connect it to your computer through the clever use of several paper clips. You're really MacGyvering this thing. All right. Upon connection, the port outputs a series of numbers, your puzzle input. Okay, data appears to be encrypted with the exchange masking addition system, XMAS, which conveniently for you is an old cipher with important weakness. XMAS starts by transmitting a preamble of 25 numbers. After that, each number you receive should be the sum of any two of the 25 immediately previous numbers. The two numbers will have different values, and there might be more than one such pair. For example, suppose a preamble consists of the numbers 1 through 25 in random order. To be valid, the next number must be the sum of two of those numbers. So 26 would be a valid number, 49 would, 100 would not, because, yeah, okay, 50 would also not be valid, although 25 appears in the previous 25 numbers. The two numbers in the pair must be different. Okay, so suppose the 26 number is 45. Yeah. And the first number, no longer an option, as it was more than 25 numbers ago, was 20. Now for the next number to be valid, there needs to be some pair of numbers among 1 to 19 or 21 to 25. Or 45 that add up to it. So 26 would still be a valid number. 65 would not be valid, as no two of the available numbers sum to it. Okay, this is just a lot of ways of describing that the first 25 numbers must have a pair that adds up to the next number. So that's interesting. It is a preamble. So the 5-number preamble. Okay, so they're line separated. That's good. After the 5-number preamble, almost every number is the sum of two of the previous 5 numbers. The only number that does not follow this rule is 127. So the first step in attacking the weakness in the XMAS data is to find the first number in the list after the preamble, which is not the sum of two of the 25 numbers before it. So it's a window, I think, right? So for the next number to be valid, there needs to be some pair of numbers among 1 to 19, 21 to 25, or 45 that add up to it. So it's a window, it's a rolling window. So a number must be the sum of two numbers in the window preceding it. Okay, so what's the first number that does not have this property? All right, let's find out. How are we going to do this? Let us create a directory and we'll start thinking about it. New folder, day 09, and new file. Coffee. All right. So these are just plain blocks. Plain. And then this is our input. So let's just capture that as input in a variable. And all right, so we're gonna have our usual 3 sections. We're gonna have definitions, we're gonna have tests, and we are going to have a section where we just run the code. One day I'll think of better words for these, or if you can think of better words for these, write them down and I will update them. Okay, so I mean, the first thing that we obviously need to do is we need to split this by new line to get an array of numbers, and we'll need to parse the numbers. So we'll do parse input. How about that? Parse input and this is going to give us text. There you go. And what it's going to do is going to take the text and split it with a new line, and it's going to map parse float. So that should give us an array of numbers, and we can test that. Let's do that quickly. We'll bring in log and assert. Require assert, and we will log parse input. All right, so this is giving us an array of numbers. Beautiful. Okay. All right, so I guess what we're going to have to do is we're going to have to iterate over these numbers, and we're going to want to just ignore anything that's within the window size, because we don't want to try and validate the first window number, or 5 in this case, of inputs. And then as soon as we get outside that window, what we need to do is we need to generate the previous window and then determine if any of these two things add up to 47. So in this case, or 40 rather. So in this case, 15 and 25 add up to 40. So, all right. So let's start looking at that. So we'll analyze stream. Analyze stream, is that really? I don't know. And this is going to take the input or the stream, which is an array, and for val and index of, or in stream, because in is how you iterate over an array. So the first thing we're going to do, we're also going to take a window size. We need a window size. And in this case we'll just default it to 5. So the first thing that we're going to do is we're going to just continue if index is less than window size. So this should skip the first 5, and then as of number 5, which is actually the 6th element in the array because it's 0 indexed, then we'll start we'll start going. And then just to verify that this is working, we're going to log index val, and we can analyze the stream. And that just takes parse input. And all right, what do we got? Undefined. Okay, great, because we're not returning anything. So number 5 is 40. Okay, cool. So this is correct. What we're doing here is correct. We're skipping the first 5. So now what we need is we need to have a window. So we need our window. Window. So how do we find our window? Our window is basically the stream, and we are chopping off. So index minus window size up to and not including index. And so let's log index val and then window, and we'll join it with a comma. Okay, so let's see, 40. So this gives us so this is wrong. We're doing up to this is up to and not including. So not up to not including is what we want, because we want the 5 immediately preceding this. So let's try this. Okay, so we got 35, which is the first number. Beautiful. 20, 15, 25, 47. Okay, cool. So we've got our window. And now what we need to do is we need to determine if 2 of those values, so what we want to do is we want to find out if any 2 of those values add up to 40, or add up to whatever the value is here. So let's find was it, find some pair. Okay, we want to find some pair in window. Or actually we'll find some pair of val inside window. So we need to define this function, and this is going to be this is either going to return a value which is going to be presumably the pair, or it will not return a value, which would be that there's no values available. So let's define this method. So find some pair, and this is a function that takes, what does it take, the value, and it takes an array of options. So it takes like window, I don't know if window is really a good word for, yeah, I don't know. Let's just give it to values. So this is the target value, and this is the values that we have to work with. So, I mean, the naive way of doing this would be for I in values, and then for j in values where or when j isn't I. So this is going to just go through the first one and then go through it again to see if for every non-unique combination, and return I j. Here we'll return the array if I plus j is target. Otherwise, we will return false. So let's try this. Let's try find some pair. Log find some pair, and we'll try it with 40, and we'll just try it with 25 and 15 to see what that gives us. 25 and 15. Let's try it with 25 and 16. Gives us, oh, it's because we're still doing this maybe. 25 and 15. Oh, I didn't. Let's try 16. False. Okay, perfect. 16 and 15. Let's try that. Okay, so find some pair appears to be working. So this is going to give us a value if there's a pair. So valid equals, so we can, I like using this not trick. So this is basically, if you get a truthy value or a falsy value, this will invert the Boolean meaning of that. So if you get something that's truthy, it'll go false, and then it'll go true again. It's just basically a fast way of casting a value to Boolean. So now let's log these, and we will log whether or not it's valid. Oh yeah, I could actually run this. Okay, so we got valid, and this one with 127 is false. So let's see what the question asked us for. It was, let's refresh our memories. The only number that does not follow this rule is 127. Okay, so the first step of attacking, what is the first number that does not have this property? Okay, so find first, it does not have this property. Find first invalid number, I guess, and that's going to take stream and a window size, and analyze stream. Right now this is just all right. I mean, analyze stream is pretty vague. We could actually just make this find first invalid number, and we could return val unless okay. In fact, window could even be that. So we don't need to have another variable. And then find first invalid number, and then if not, we can return null. Okay, so let's try that. So this gives us 127, which is what we want. So let's assert that. assert 127 is, whoops, there you go, cool. And now they want us to do the same thing with the input. So let's try that. Input, cool. Module.exports. Ooh, these numbers get big. And I remember the window size here was, the window size was 5. So we're actually going to change that to 25. So this was 5, and that should still work. Cool. And then what we're going to do is we're going to do 25, and we want to just log it. Log, parse input, wire, input. This is why I usually like putting things like require input last, so I don't need all these distracting parentheses. Okay, so this freaked out, cannot find, oh yeah. So that's the answer it gave us. Let's give it a try and see if that's what they like. That's the right answer. Beautiful. Okay, continue to part 2. Before we continue on to part 2, I'd like to flip the window size. So here where we have stream and window size, I'm going to flip it. And that makes us, it forces us to put this window size in. And we're always going to put a stream in. And that way we can have this nice 25, parse input, require input. We don't need all these parentheses that just get in the way. And that gives us the same value, which is 2186024, I think. Is that what it was? Yeah, okay, beautiful. Okay, so feeling all right about this. So let's preemptively create our second file. All right, and we can, while we still have this one open, just grab these defs from the bottom, and then let's go read our input, and we'll copy it. Okay, so in the final step, or the final step in breaking the Xmas encryption relies on the invalid number you just found. You must find a contiguous set of at least 2 numbers in your list, which sum to the invalid number from step 1. All right, so wow, find a contiguous set of at least 2 numbers. So it could be multiple numbers. Yeah, wow, okay, again, consider the above example. Okay, so 15, 25, 47, 40. In this list, adding up all of these numbers from 15 through 40 produces the invalid number. Of course, the contiguous set of numbers in your actual list might be much longer. To find the encryption weakness and together the smallest and largest number in this contiguous range, in this example, these are 15 and 47, producing 62. Okay, all right, so they want us to find a window, any previous window, where the whole thing adds up to the number exactly. And then they want us to add the min and the max of that array together. Okay, so part 2. So, oops, input. Here, let's, whoop. There you go. Come back here. Okay, so yeah, few things have changed. Parse input, it's fine. Still parsing it just like that. Find first invalid number is something we're no longer doing, and we no longer care about a window size. So the window size will be variable. It's like whatever we want to do, man. Find some pair is no longer just doing a pair. So this, we're gonna have to be a bit more clever about how we find our list. So let's first of all, let's rename this. Find some list, and then target, and this is gonna be basically did it say it had to be the previous or just any in the previous? You must find a continuous set of at least 2 numbers in your list. So it doesn't say that it has to be previous. So it could just be the whole list, which is why they say it has to be at least 2 numbers, I guess. So you can't just find the number that you're looking for and be like, hey, 127 adds up to 127. So I guess we're going to feed the whole stream into here. And so we could do something similar to what we did here. And I think basically what we'll do is we'll start at the first number, and we'll start adding the successive numbers. And if we hit the target value, then we will keep that and return the numbers that we've seen so far. And if we exceed the number, if we go over it, if we like pass the number, then we'll move on to the next offset and we'll start again. So like in this case, it's like 0, 1, 2, 3, 4, 5, like this. And if we want to get to 5, let's say, like we'll start here and we'll say, okay, so we got 0, okay, we got +1, and then we got +2 is 3, and then we got +3 is 6. No, we've gone past it. So we'll start again. We'll say, okay, so we're gonna start here at 1, okay, and we add 2, which is 3, and then, oh, I wonder if this is actually, this is only just because it's 0. It's 3, okay, we've gone past it. So this would become 3 and 6. And then here we'll start at 2, and then we'll add 3 to make 5, and this is our solution. So this is what we're looking for. This is basically what the algorithm's going to do, what this method's going to do. Cool. So to know this, we're going to need to know our index. Usually, I like to put these as arguments that have a default value, just sort of like this is part of the instantiation of the method. And it allows us to override them later if we decide that we need to override them, which sometimes happens, but also it's kind of nice to have them up here in the definition. So we've got index of 0, and so we're going to say for I in, I mean, we could do like the old school for loop where it's like, I equals index. But what I'm going to do, values. So this is the start index. Let's call it the start. So I index in values, and we'll start at start, and we'll go to values dot length. So we're gonna need to track our sum. So okay, we're gonna need to track our sum. So our sum, we can track our we can track the array of values that we've seen. So values. So we're gonna need this out here. Oops. I guess since we're just grabbing like an ever expanding window, what we could do is we could just copy we could just slice the array and sum it. In fact, that's probably a way smarter way of doing this rather than iterating through it. Yeah, so for I in so this is basically what we're doing. I in start in values dot length. We are going to value start I. Okay, and we're going to reduce. So what we're going to do is we're going to basically just slice out the array, and then we're going to reduce that as a sum. So memo equals 0, val, and then memo plus val. So the I here is going to start at 0. Oh no, this is a value index. Index reduce. So this might be wrong. This is up to, what is this, up to and including, or up to not including. I think that's up to not including. So the first index is going to be 0. So this is going to be a start of 0 and an index of, so this is going to be start plus index, which is what we want. I think this is correct. Okay, well, let's find out. And we're gonna say sum equals, I guess what we should do is we should capture this. We should say this is gonna be our window, and then we can sum the window, reduce that, and if sum is target, so return window if sum is target. So let's find sum list. Let's try this. This is going to definitely need some debugging. Excuse me. Let's cut that. And now, what are the assertions that we need to make? So the only assertion that they give us is 15, 47, 62. So 15, 25, 47, 40. So let's just log find sum list, and we're looking for 127. Oops. And what are we giving it? The stream, which is parse input. So watch it blow up, and it did. Okay, it didn't like, oh, it's supposed to be array syntax, I think. Yeah. So for IDX in, what is it saying? Indexes do not apply to range loops. Oh yeah, so we got okay, so we're making a range loop, and a range loop is different from just an array of numbers. So start. And it's the index that we care about. I guess what we want to do is 0 up to including values length minus start. So that would give us I, and then I, and we're not using index anymore. So let's do that. Okay, so this is a different error. Reduce of empty array with no initial value. So continue. I guess what we can do is we can say 1 up to that, because this is the offset that we're going to do. And then this would be, yeah. Okay, so let's try that. So undefined. So this is not what we wanted. Let's start logging out what the windows are. Window. Okay, so these are the windows that we're returning. So the first one is 35, 35, 20, 35, whatever. Okay, so is that 35, 35, 20, 35, 20, 15? Okay, cool. So that failed, and it should get to the end of the list of 576. Okay, and then it goes to undefined. Okay, so this worked, but this was only the first iteration. So what we want to do is we want to say, well, start is less than values.length. We want to try that, and then what we'll do is, if we get through this loop and we haven't returned yet, what we'll do is we'll start plus equals to 1, and we'll restart the loop. So let's give that a shot. Okay, 15, 25, 47, 40 is what we got. And that is what we wanted, 15, 25, 47, 40. So that's find sum list. And then, so what are we actually doing? We're find encryption weakness. So And find encryption weakness, we just need to get the sum list, and then we need to find the min and the max of the sum list. So find encryption weakness, and we don't care about window size anymore, we just care about stream. Okay, and so, and we still need to find the number from the first invalid number and the sum pair from earlier. So we actually need to keep these because this is what's going to inform how we find our encryption weakness. Okay, so the first invalid number is what we're going to be putting in here as the target. And then this is our stream. And then, okay, so we want to get our sum list, or our window. So this is going to be window equals find sum list, target, stream. And then what we're going to do is we're going to find the min and the max, and we're going to sum them together. Math.min. Oops. Actually, window. And we're going to do math.max window plus math.min window. That's what we're going to come out with. Okay. So find encryption weakness. So we want to assert that, what did they say? 62 is find encryption weakness. And in order to find the encryption weakness, we want to find the first invalid number. So the target, I guess what we could do is we could just say find encryption weakness of the stream, and we could say target equals first invalid number stream, and then window. I guess we want to pass in window size as well. Oops, there we go. Window size, and then window size stream. So our window size in the first case is 25. Find encryption, and then parse input. So let's see if this works. It does work. Okay, so we did that correctly. Okay, so we found the encryption weakness, and now what we want to do is we want to find the encryption weakness with a window size of 25, and then we're going to parse that input. Okay, so let's give it a try and see what we get. We get this number right here, which we can put into the answer field, hit submit, and pray. That is the right answer. Cool, we're 1 gold star closer to saving our vacation. Awesome, okay, so that went smoother than I thought it would. I guess what we can do now is we can take a quick look and refactor a little. Every time I use a variable to hold a value, like just to pass it into something else that kind of like upsets me just a little bit, it means that I'd like to see if I can get it a bit more functional. Like I could do something like this, but I find that that's harder to read. So it's always a trade-off between readability. Like, I don't really think this makes a big difference in execution if I have to save this to a variable and then feed that into another function. Certainly it will help if I need to use it twice, like I do down here. So I'm using window twice. This is effectively just memoizing the value of that function, so I can use it again 2 times. In this case, I'm only using it once, so this is like a prime candidate to just like drop in as an argument. But in that case, it just makes the line really long. It makes it hard to read. I'd have to use parentheses to denote that these are the arguments for this method, which to me is sort of like a code smell. It means that it's not clear enough. if I have to be explicit about the grouping. And so that's a really good candidate for leaving it on its own line and just capturing the results in a variable. So I'm okay with that. So find some pair. Yeah, this is, I mean, it's a nested for loop, but it's pretty clear. We don't really have to, I don't think, return the pair, but I don't mind returning the pair. It's a truthy value. I think the only way it would be a falsy value is if it returned an empty array, which it will never do. So I think we're fine there. Parse input, again, this is just taking the text block, splitting it, mapping it through parse float. Again, I like using parse float to parse integers in JavaScript. I mean, there's no such thing as a float, really. I mean, they're all just numbers. Parse float makes the assumption or forces the assumption that it's base 10, whereas parse int, I think, might default to base 10, but like there's cases where it's like if there's a leading 0, then it might think it's octal, or like, I don't know. I've had that bite me in the past, and it's always like, oh, whenever you use parse int, you should really, you know, the second argument to that should really be the base that you're parsing into, which should be 10. And it's like, yeah, or you could just use parse float, which basically assumes base 10. So I like using parse float for numbers that I know are supposed to be decimal, just because it reads easier, and I don't have to worry about that second argument gotcha. Find some list. So this is looking for target. It's looking for values that add up to target in a window. So here we've got this seemingly infinite loop, or this open-ended loop that is just looking for from 0 until we pass the length of the array. And basically what it's doing is it's just going through and it's slicing that array into ever bigger chunks, which is what it's doing here. It's slicing the array into ever bigger chunks. It's taking that window of the array, or that slice of the array, and it's getting a sum. It would be nice if there was like just a sum function built into JavaScript, but they always say, oh, just reduce the array. Like, it would be cool if you could just have a function that built into the language that you don't have to write yourself every time, where it's just like sum, and you know, it takes args, and let's refer to as arguments. But it would be cool. Arguments array, arguments like reduce. So we're going to create an array out of these arguments and reduce them. So yeah, so we could just do some window like that. I wonder if this works. No, it's breaking. Why is it working? Sum is not a function. Oh, sum equals sum. Here, total. Here, how about that? Math max is not iterable. Okay, well, we broke something. Is this supposed to be new array of arguments? I don't know. Maybe arguments like that. No, okay. Well, math max is not iterable. Well, okay, so we're breaking it pretty good, so let's just leave it as it is, but I don't know. We can actually take a look at that later, because it would be nice just to have a sum function. In fact, I think we've probably done that. Yeah, equals, oh no, it's just here. Anyway, that would be nice. We could just read a little easier, and then return the window if sum is target. So basically, if we've hit our target exactly on the head, we return the array that got us there, and otherwise we just keep going. In fact, this is going to just go through every combination. This isn't going to jump to the next loop if we go over our target. So we could probably speed this up. And I forget what it is. Is it next, or is it continue? Continue would continue this loop. Can you continue? Yeah, continue if sum is greater than target. So we could try try that, and this should still give us the same answer. I wonder if it does it in fewer tries. So let's check that out. We'll say loops equals 0, and then we will do loops plus equals 1, like that. So let's try it, and then we want to so sum is target, we're going to return window, but we also want to log loops. Log loops. Okay, cool. So 11. So if we remove this continue, if the loops are larger, that means that the thing that we did didn't work. So 11, 74,000. All right. So yeah, okay. So this actually saves us some execution. So that's nice. So we should probably, this is where it starts to get like a little bit complicated. So let's leave some comments here. This is, did we find the target? And then this is, did we surpass the target? And then we can get rid of the loops variable because we don't care about reporting it anymore. This is no, this would be target not found, or like, let's try the next offset. Okay, so it still gives us presumably the same answer that we copied and pasted. I hope so. What did it say? Your answer was, yeah, 9.5. Okay, so cool. I guess this, everything we talked about here is the same there. We assert, we log, don't need that extra line. And again, don't need that extra line. No, Siri, I'm not talking to you. Thank you. Okay. Yeah, I feel pretty good about it. Okay, cool. Well, let's commit it. And that is day 9 wrapped. All right, cool. All right. I guess see you guys tomorrow for day 10, which first day in the double digits. I'm sure it's going to start getting increasingly more difficult, and maybe we'll have some nice multi-hour sessions in our futures.